Today we're going to see a summary of the steps that you need to model hydraulic systems. I want to call your attention to a chapter in a book that I wrote that explains step by step this process. So we are going to take a look at that. The book is called Bond Graph Modeling of Engineering Systems Theory and Applications on Software, okay? And that is edited by Professor Wolfgang Borutsky, who is a professor at the University of Applied Sciences in St. Augustine, Germany. And in here, on this chapter 11 of that book, you can see I wrote this chapter with you in mind, with the student who is trying to learn what bond graphs are like, and this will contain the step-by-steps also for hydraulic systems. I think I called it automating the modeling process, automating the process of modeling and simulation of mechatronic systems. That's the title of this chapter. And then here you see there's mechanical systems, there will be electrical systems, and step-by-step procedure. So you can take a look at that in the reference, but part of that deals with the hydraulic systems. Let's see, we have okay, here we go. This is on chapter 11 of that book. It's called Systematic Bond Graph Generation of Hydraulic Systems. I would like to concentrate mainly on the pictures on the right hand side. I'll let you read later on the steps on the right up in there, but I want to explain it to you and see if we can do this. This is a simple hydraulic system. You can see here, it's a simple hydraulic system. You have a tank in here, and there's another tank in here. There's a right right off. There's a little bit of a mistake in here. We need to correct it here. If we could take the part of the tank out in here. All right, let me tell you what I'm trying to say. In here, we are going to see that this part, this thing here, this is not the RI in there. This is a C element in here. I don't know why it's a misprint in here, just like the C on the other side. So what do you have is that we have a reservoir and we have a source giving us a flow here, and then you have a connection between this tank and this other tank, and then you have a flow valve control, and then you have the flow going out to this reference point, which we call it atmospheric pressure. So the first step that you have to do is to recognize and put a one junction for every distinct flow of the system. So you see we have put it over here, and over here. Yeah. So that's the first step. Just identify the distinct flows and put the one junction. So you can see you have identified this. This would be the flow out here, and the flow in the pipe between the tanks, and of course we have the input flow in here. So we put the one junction first, and then the second thing that we do is to put the attached elements that see those flows. Like in this case. In this case, you have this. This is the flow of water to the atmospheric conditions here. So in here, what we have is a source of effort with value 0, which is the reference pressure for the atmospheric pressure here. So the way we express this is by this half arrow, meaning one of the signals is 0, and in here that's what we have, and the E is 0. And here the R element is the one that is attached to this junction here. Yeah. And then we have in here the R element in here, and then you have the inertia element, both. And then in here we have the source of flow, of course. Those are the elements that experience these flows. Okay, what do we do next? We put 0 junctions to indicate the relative or the differences in flows. So in here we have that this flow minus this is this. We also have that this flow is this flow minus this one. And then of course this one is attached to the one junction up here. But the point is that we created, using the zeros, the difference in flows between these two elements. That would be the 0. Okay. So we attach the we make the 0 junctions for the difference in velocity. So this minus this is going to be the flow going into the tank. This minus this flow going into the tank. And then we have to put to complete the elements that see those differences. When you complete those elements, you see this in here. And then we have this in here. And we have a discharge in here. So this pretty much builds the bone graft model. Doesn't have causal marks yet, but I think the computer is going to do this. In fact, we could practice here. The computer will complete the causal assignments, put bone numbers, and then make reference to variables using those. So here we can, okay, you see, we can practice the idea of putting the causal marks. This is a source of flow, so this is supposed to go like that. But the one junction receives one flow, the others have to be efforts. Okay, right here. Maybe, yeah. In here we have this. This in integral form, one in integral form, the other. Okay, so we have this 0 here. And then we have this I element in here. Once you do that, these others have to be like this. All right, we have to assign it to the other right here. And then we'll assign the causal mark here. That makes this like this. And when the zero junction F14 makes the other ones out. Yeah. And then we have their element over here. This is done by hand, but CAMG will actually produce this. And using software, you can do this, eh? Okay, so these are all the causal marks and the bond numbers. But that's how we model hydraulic systems from scratch to ending up into the CAMG software. And then, of course, from there on, we would like to extract the information from the bond graph and turn it into MATLAB and simulate.